Hello all, very good morning. Thanks for joining the session. Let me share my screen. Hope you are able to see my screen, I believe. So this is the demo 2 as part of our Java real-time project using the microservices architecture and React.js as the UI library. So the project name is AI MIA, Market Insurers Analyzer. We're going to use the artificial intelligence capability also in our market insurers analyzer project, which is basically designed for the P&C, property and casualty domain, insurance domain needs. So the AI MIA, the project AI MIA is for what? AI MIA is designed. It is designed for the P and C, properties and casualty insurance domain needs. Okay, so the AI MIA basically in P and C, domain, uh, we can think of the following actors, right? So who are the actors? The first is insurance company. The first is insurance company. We call it as insurer. Insurer. That's the reason if you can see the project name is what? Market Insurers Analyzer. Insurers Analyzer. I mean insurance companies. It will analyze the insurance companies who will provide the best coverages for the property owner needs. However, in PIC domain, we can think of the following actors. So insurance company, which is called as an insurer, and then the property owners, we can think them as the insured. And we have the insurance agents, and we have the property brokers. So these are the four actors, at least we can think of in our AI, in our MIC, right? So market insurers analyzer, in our properties analyzer, we can think of these four characters, four actors, and our product will be designed in such a way to help these four actors. So how it will help to the four actors? So there will be a functional understanding, functional requirements understanding, and each and every actor what he can do. So we have to understand that. However, in a glance, as we discussed in our demo 1, so AI MIA is a product suite designed for the P&C insurance domain needs, and AI MIA is a product suite which helps the insurance companies, property owners, insurance agents, and property brokers. Nowadays, if there will be no AI MIA, I mean, if there will be no market insurance or insurers analyzer, assume if there will be no MIA, then the problem we discussed in our last think if we have without MIA, right? So without MIA, think this the the problem that the property owners might face is when property owner, right? When property owner submits the property quote, right? So he will, when the property owner submits the property quotation for the insurance coverage. So that's what is here, right? So let's say this is the property quotation. So when the property owner is filling this quotation, and once he fill this quotation, right? So what is his property is and what is his property type, etc., etc. So once he filled all this information, when he click on the create quote, this quote will be sent to the insurance companies. But whether the insurance companies will accept this quote or not, the property owners, most of the cases, they don't have the backtracking acknowledgement information. They have to wait for some time. Sometime maybe a 30 days, sometime maybe a 60 days, sometime maybe they even do not get back the confirmation back about their application. So application tracking will be there, but what happened, why the application was rejected, maybe it don't have the proper response back. So that is one of the reason. And second reason is what? The time when the property owner submits the property quotation for getting the insurance, property insurance, then the property owner has to wait for a longer period of time to know whether the quotation has been approved or not. That's the second problem. So these problems will be eliminated using our market insurers analyzer, because our market insurers analyzer have a fixed set of flow. So what is that fixed set of flow is just a glance I'll explain, but we will discuss this flow in depth. But if you can see the fixed set of flow, the property owners. So this is the actor who is the property owner. So these property owners will submits the property quotation. What does that property quotation contains? You can see the property quotation contains, what is the quotation type and what is the coverage he is looking for. There is a coverage type: standard, basic, comprehensive. So these coverage types again will be decided by the ACMA itself. For example, standard coverage type. So standard coverage type will cover a few things in the insurance, and basic will cover few things in the insurance, with property insurance. Like basic may cover the fire accident, wind accident, or maybe any other uh, you know, natural disasters. And standard may cover the basic plus any other disasters occurred. Maybe the snow disaster sometimes can occur. Snowstorms, when snowstorms happen, right? So the maybe sometimes the entire property will be sink in the snow. Due to that, maybe equipments may not work, or maybe the property get damaged. So that kind of coverage also will be provided if they choose the standard one. If they choose the comprehensive one, maybe there will be additional standard plus basic plus, again more, the benefits will be provided by the insurance company. So based on the type of the coverage, the court will be having the type of the coverage that the property owner is looking for based on the property owner's estimation. So where the property owner will have the estimation, the property owner will have the estimation on the properties. So if you can see, for example, this is the one property. So this property is talking about what? If you can see, uh, describing the property information, right? And then what is he is looking for? What is the appraised value, or what is the replacement cost, and what is the market value? So exactly what insurance value he is looking for. If something happens, then the insurance company should have to provide that insurance value. So this is the market value which he might expecting, right? And how much amount he may pay as the EMIs. Let's say every month he may pay $300 or maybe $500, right? As a EMI. So that information also he will enter, and he will, complete the quotation. So when the quotation will be submitted, so if we submit the quotation, let's say it's a standard quotation, or maybe let's say it is this one. So when the quotation is submitted, right? So that now the quotation has been created. So this quotation when created, there will be a this quotation will be sent to the agent, right? So this quotation will be sent to the agent. Then what agent will do is, then the agent will see the quotation. For example, let's say for this quotation, he can see the quotation details like this. Probably he'll go here. This service is not running. Mm, Yeah, this is one, right? So let's click on this. So you will see this quotation, right? So once the quotation will be sent to the agent, then agent will log in into his system, and then agent will be able to see the quotation. So by looking into this quotation, whether to accept it or not, he will either accept it or he will reject it. So if he'll reject it, then we have to inform back to the property owner why the quotation has been rejected, and we also have to you know uh, give the recommendations. Hey, your quote has been rejected because you quoted more by paying the less EMI. So your recommendation is either you decrease the coverage amount that you are looking for, or maybe you increase the EMI that you may be able to manage it. You may be manageable to pay the EMI for every month. So that recommendations we will send, and also we will send the uh, within his quotation, like let's say $500 per month, equal payments. He is looking for $10 million insurance coverage, but this insurance agent is not providing, but maybe other agents may provide. So that other agent's information also we need to provide to this um, property owner as a recommendation. For that, we will use our Spring AI, artificial intelligence. So we'll use the Spring AI, and then we will send the recommendations back to this user. So this is just a flow, but each and every uh, module here, I mean to say each and every service here will have a detailed, um, you know, functionality and detailed requirements we need to understand. However, in a nutshell, you might now got the picture about the project, what we're gonna do. Now, finally, what it will happen is, let me just scroll down and then show you. Give me a moment. Just give me a moment. I have done something. Sorry for taking your time. Mm, Give me a moment. Sorry for taking your time. Let me just scroll up. I already have drawn something, so just would like to showcase you. Okay, not an issue. I'll draw one more diagram. Okay, finally, what will happen is we'll discuss our architecture. But before discussing that architecture, what will happen is, so this is what our MIA, right? So market insurance analyzer. So this market insurance analyzer will have the um, actors like the our modules, like we can say the agent service, right? And we have the quotation. So quotation service, um, quotation service. So what will happen? This quotation will, when sent to the agent will have a workflow whether the agent will accept the quotation or reject the quotation. If the agent will accept the quotation, then it will be sent to the another system, which is now already using, let's say, the guideware. Guideware is the product which is using for the PNC instance domain needs. So this product have the various modules. Like one of the module is the policy center. So policy center. So once this insurance agent accepted the quote, then it will be sent to the policy center, and the policy center will take the quote, and then it will prepare the insurance, right? I mean to say, the quotation will be converted uh, to the insurance. So here the property insurance will be created. The all the insurance details like insurance documents, monthly payments, details, and all will be sent back to the property owners from this system, right? So if you can see here the property owners, then all the information will be sent back to the property owner. Now the point is here, our MIA is helping the the insurance system. I can say it as the insurance system, right? So the MIA is helping the insurance system by providing the accurate quotations to the insurance system, verified quotations. Who will verify? The agents will verify. So these agents are the employees employed by this insurance system. For example, if we can take the Geico insurance, or maybe any other insurance, if we can take, so that Geico insurance will have the insurance agents who are the employees of the Geico Insurance Company. So that Geico Insurance Company will employ the agents. So that agents will approve or reject this quotation according to the policies that were available in the Geico system. So once the agent accepted the quotation, then it will be converted into a policy. If the agent rejects the quotation, then it will be sent back to the owner as a recommendation, like why the agent rejected the quotation and what are the recommendation and all, right? So if you can see the entire system, how our system is, so you can see entire our system like this. Hope you all able to see my screen, right? So this is what our system architecture. So we'll have the security services, we'll have the business services, and we'll have the infra services. So the security services, if you can see, right? So for example, when any broker or owner or property owner or property broker or any agent will log in. So it's something like this. So slash acma-properties, right? So this is our website, Acma Property Analyzer website. So from this website, when the user is login, right? So it went to what? It went to our IDP. So where is that IDP? This is the IDP, right? So this IDP is what the key cloak we are using. So which contains the directory server and also the database as a secondary store. So this IDP contains all the users of type agents, brokers, admins, and users of type property owners, right? So now let us log in with the uh, login as an admin. Let me log in as an admin. I'm now logging as an admin. Yes. As soon as I log in as an admin, I will be able to see how many quotations submitted so far, total number of quotation, total number of owners onboarded, total number of brokers, that we have in our ACMA system. And then it also shown us the total number of agents we have, and how many quotations were created, and then how many quotations were approved. So that statistics it will show. And also the admin can go back to the quotation details and see the quotations, and then can go to the properties details, the properties registered by the property owners. But if you can go back to the owner's case, that means the property owner's case, the property owners can be able to see the properties that they were created for which they want the property insurance. So the beauty of it is what they can register their properties details with the ACMA system at only once, but using that property details, they can create the quotations, n number of quotations they can create using this property information, right? Let's say they were created one quotation today, and that quotation might not be approved by an agent. Then what will happen? That quotation will be expired after some time. So once the quotation expired, then the status will be changed to the expired, right? So again, the property owner can come back and then create one more quotation for the same property, maybe by changing the, uh, coverage details, or maybe the policy type. He can change and then he can resubmit. That's the beauty. That's the beauty of the MIA platform that we are offering. But the point here is, what is the revenue model for this MIA? The revenue model for the MIA is, if you can see again our website, the revenue model for the MIA is, we have the pricing plan, right? So we have the free plans available for only the property owners, and we have the business plans available for the agents and in the brokers. So they have to purchase these plans. That is one thing. And second thing is what? For every quotation, we will be charged some amount, right? So maybe every quotation might be $5 or $10 might be, right? So because there is a lot of system involved, there is a lot of workflow involves in creating the quotation to approving the quotation or maybe rejecting the quotation. There is a workflow, and there's a lot of process involved in it, which might be cost prone. So that cost prone will be paid by the property owners only. So in that way, our ACMA will get the revenue, right? So two ways it will get the revenue. One is by onboarding the customers. The customers are of the type the property owners, agents, and then the brokers with the subscription plans like monthly plans or yearly plans, right? So our project, we're going to give it as the SaaS model. That is one thing. Next thing is what? For every quotation that the property owners will submit, and they will be charged, but not right away when the quotation created. When the quotation approved or accepted by the agent, at that moment the property owners will get charge. In fact, the property owners have to pay the charge for that quotation, because that quotation is going to be converted into an insurance, right? Insurance policy, right? So real insurance, the quotation, whatever they filled, that quotation once approved by the agent, it is going to be converted as a real insurance, right? So for that, so at the moment it will be converted to a sorry, yeah, at the moment it will be converted to a policy, or it is ready to convert to a policy, right? Then we'll inform the property owner, hey, congratulations, your quotation has been approved by the agent John, and to proceed further, give us the consent, and please proceed by paying the quotation charges. So he'll pay the quotation charges, and that quotation will be moved into the uh, you know moved into the another Kafka system, and from that Kafka system, then the insurance system will pull, and then they will start build writing their policy documents and all. So everything will be the event driven here. I mean to say, the quotation service is one service and agent service is another service. Quotation has to flow to the agent, right? So from here to here, it should have to flow to agent. So it is an event driven, right? So for that one, we're going to use the Apache Kafka. So when the quote is created, it will be moved to the Kafka topic. It will be sent to the Kafka topic. Probably I can showcase it. Uh, Give me a moment. You can see this. So event received, right? So this is what the agent service. Just now we created one event, and this is what the event received by the agent. And this is the, the details of our uh, quotation, right? So this is the owner, and then ID is 704. 704 ID, in the sense, if we go to the properties, we can see, not properties. 704, probably this one. Yeah, this is the one, right? So then now the agent received it. So as soon as the agent received it, agent may be accepted or rejected it. If it will be rejected, then the rejected leads all will be moved to another Kafka topic, like rejected quotations. And that rejected quotations will be processed by there. We have another system that is recommendation service. Okay, now coming to this system architecture, you can see we have the IDP, and this IDP will be integrated into the microservices user management service, and then the authn service. If you can go here, we have those two services here. So authn service and then user management service. This user management service is responsible for onboarding the users, whereas the authn service is for providing the authentication and then authorization. You may ask me a question. Already we are using the IDP. So why again this authentication service is needed in the middle? Can't the directly UI, whatever we have here, right? So that UI can directly go and then, integrate with the IDP. It can be, but public facing, right? UI is always public facing. I mean to say, this is the application will be accepted over the public network by the owners, agents, and then the brokers, right? So why we need to expose our internal system details? So it is not always good idea to expose our internal system details what we are using. So and hence we have written this authn service as we're gonna write this authn service as an orchestrator basically, which will abstract our internal system details and which will provide the authn services on behalf of our IDP to the public faced applications. And if you can see here, every request come to our market insurance analyzer, every request will come to the API gateway. So the API gateway will be again the public facing one. I mean to say this will be in the public. Uh, uh, we're going to create the VPC, virtual private cloud, right? So in the virtual private cloud, if you can recall the AWS VPC concept, there we have a private subnet and then the public subnet. So all our microservices will be in the private subnet, so they can't be accessed directly. But our gateway will be in the public subnet. So this gateway can be accessible over the the gateway network actually, right? I mean to say the VPC will have the gateway. VPC will have the um, network gateway, and over that network gateway, our API gateway will be accessible to the external um, applications or maybe external customers. Like here is our UI, right? So here is our UI. Let me just take one screenshot of that UI. Give me a moment. Yeah, so here is our UI. Now, if you can see, everything is a REST call behind the scene, because this is the React.js, and we are using the stateless communication. I mean, this is a front. This is what the single page application SPA, and which is refreshing a particular portion of the page and then invoking a backend REST call to get the data. So that's the benefit of it. And if you can see here, resize, this is what our UI, isn't it? So UI will always makes a call to the gateway. So it will always makes a call to the gateway, not direct backend services, right? It will make a call to the gateway. Now, gateway, at the gateway side, we have the lot of things actually. So just okay. Fine. So the gateway end, we will do a lot of things, like the all these services, right? I mean, the all the services which are using consumed by this UI. So all the services will be invoked using the TLS protocol, and TLS termination will be happened here. I mean to say the subject verifier of the a particular when the particular API is hit with the HTTPS protocol, then that SSL termination will be happened here, and then the SSL check will be happen, right? Whether the certificate is having the proper domain or not as the subject name. Then if the proper domain is there, which is accessing is there in the is there in the certificate, then the API gateway will allow that request further. And also we're going to write the resiliency on the API gateway. So we have a bulkhead pattern, and then we're going to implement the rate limiter, so many things. And also every API is the secured API, right? So as soon as the user has been logged in with the user's JWT token, the API should be called, meaning the gateway should be called with the JWT token by giving it in the request header. Now the gateway will take that JWT token from the cache, Redis cache. So if you can see here, the auth service, as soon as the authentication has been done, then we are putting the details into the cache. I believe we can access it if I'm not wrong. Let me check if I can showcase that. Mm, Give me a moment. 5,000. Give me a moment. Let me check if I can access that. Localhost. What is the port number? 5053. 5053, I guess. 5053. Okay. Now, this data, add Redis database. Let me add test connection. Okay, I think this is not, we are using another Redis tag. You can see this is the Redis tag we are using, which is accessible on 8001. Let me try that, 8001. Let me try to log in. Open. I didn't recall this password and all, but let me do a test connection. Okay, sorry. Right now I'm not able to access it. Maybe I need to go back and then see what details I have. I didn't remember what details we gave. But somehow we use the username and then password, it seems to be. Give me a moment, guys. Let me check and then showcase you. Meaning I want to show you, how we are storing the tokens, right? So mm, hmm, the username is username, and then password is username, and then password is password. Yep, connection success, apply changes. Now go to here. Um, okay, we don't have any data yet. Now, if we log in, then the token will be here for sure. Let's see. Okay, let me just go back here. Okay, let me. Already I have logged in, right? Okay. Um, Let me use some other browser just in case. Login. C0509. So probably it should now store the token for sure. No. Okay, maybe I don't know, maybe any issue happened or issue is there. So I think we need to see, meaning the services we need to see. But what I would like to showcase is here. So yeah, what I would like to showcase here, the token will store here basically, right? So once the token is storing here, then probably there might be a little code issue. However, so when the token will be stored in the Redis cache, then when the request is come to the gateway, then gateway will go to the cache and then verifies the token that is coming in the request is matching with the token that is there in the cache. If it is there, then it will do the introspection to our IDP to verify the token validity. So if the introspection is giving the true, then only the gateway will forward the request back to our backend services over the service registry by using the client side load balancer. Okay, so this is what the flow we're gonna implement actually. So every service is protected. Every service is protected with the API gateway as a front controller, or maybe the front gateway we can say, not controller, but front gateway we can say. So API gateway will do a lot of things, like it is doing the caching, it is doing the throttling, it is doing the rate limiting, right? It is doing the token verification, token token introspection, I mean to say token introspection, and then it is also providing the retry mechanism if something went wrong, or maybe at this moment if the backend services are busy or maybe they're down, so it will ask the applications to retry after some time, or it will hold the request for a specific period of time and then it can retry after the you know backend services up and run. So it will have the circuit breaker mechanism to verify that. However, we're gonna implement all those things. Okay, coming back to our business services. Now I explained the security services and we discussed the infra services. Now these are the business services. So as I told, right? So when the property owner will creates the property quotation, and that property quotation will be sent to the agents. See the color here, I indicated with the different color. So owners will create the quotation. Then the quotation will be sent to the agents. Then the agents maybe the quotation will be sent to the agents, and then quotation will also be sent to the brokers, right? Now the agent may accept the quotation or may reject the quotation. So accepted quotations will be converted to a policy. Rejected quotations will be sent back to the property owners as a recommendation. See, the recommendation service is sending the recommendations to the property owners. And this recommendation service is using the market analyzer, which is integrated with the artificial intelligence. I mean, Spring AI we will use here. And this will go to the external market, analyze the market for the quotation, what the property owner submitted. Were there any insurance companies which are offering the insurance? So that details it will pull, and then those details it will aggregate here and then send as a recommendation to the property owners. Then property owners will see that recommendation and maybe they'll create one more quotation with the updated insurance coverage details. And again, once you submit the quotation, it will be again go to the same flow, right? So again, go to the same flow. Finally, the two things here, approved quotations will be converted to a insurance. Rejected quotations will be converted to a recommendation. And that recommendations will be again sent back to the property owners. Then, as I shown, right, we also have the plan service, where the plan service is for owners, agents, and then the brokers. So the plan service will provide the various plans where the owners, agents, brokers can subscribe it to our Atma system by paying the by choosing the plan and then by paying accordingly. Then this notification service, right? So we're going to use the send grid here, and this notification service will send the notification. I mean to say, see this one, the agent, right? So when the quotation created by the owner, as soon as the quotation received by the property code service, right? This quotation will be enriched. This quotation will be added with more details analyzed here, and then that quotation will be sent to the agent. So how it will be sent to the agent? So this quotation will be sent to the agent using the Kafka as an event. Once the event has been received, this agent management service once received the event, then that event, whether accepted or rejected, whatever it is, right? So it will be this agent. First of all, this agent service will do what? When the quotation is received by the quotation service, and that quotation service will push the quotation to the agent. You may ask a question, sir, directly owner management service, I mean properties management service can't push the quotation to the agent. No, it can't, because there is a lot of refinement of the quotation will be happened in the property quotation service. So microservices are what? Single responsibility services, right? So I don't want to merge the multiple responsibilities into a single service, which we will deny the principle of the microservice, right? So that's the reason. Let's put everything related to the quotation refinement into the quotation service only. Then that quotation will be sent to the agents via the Kafka as a event. So when the event will be received, then the agent database will have all the agents, right? Let's say the property owner created a quotation. The property owner is in the, let's say, Amirpet area. Then there might be agents in the Amirpet area, right? So the quotation should have to be reached to a particular agents who are in the Amirpet area. If the quotation will be reached to Kukatpalli area agents or maybe Gachpoli area agents, right? It might take a time for those agents to go and then visit the site. Maybe there might be some delays, or maybe they have their own proper priorities in their area. So it will be a little time consuming again for the property owner to get back the property quotation details or status back. So to solve that problem, we will send the quotation to the a particular address, agents who are in the particular address. So those are all the agents will get the quotation details and using the notification service. So notification service will send the quotation details as a notification to all the agents. Now the agents will see the quotation like this. Um, as I shown, right? Let me go back to, so the agents will see the quotation like this. So yeah, so this is the email. I mean, this is the link. This is the link we're going to send to the all the agents in the email. So we're going to use the free marker for that. Free marker is a Velocity or Apache Velocity or Apache free marker. We have the templatization engines for which the starter support there in the Spring Boot. And using the templatization engine, we will prepare the template. And that template have this link information embedded. So when the agent will click on that link, right, then the agent will be landed on this in this page. Then agent can see all the quotation information. Then agent can either approve it or either reject it. So that is how our entire components behave with respect to the end-to-end flow, right? Hope you got it. So the business services, they are designed for the their own each and every responsibility, right? So in that way, um, each and every microservice will communicate in a event 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 driven way and fulfill the requirement. That's it about the system architecture and the components involved here. So coming to the technical stack, if you can see the properties management service, we are using the Spring Boot, and of course it's a microservices architecture. It will it's so properties management service will use the MongoDB, so not the MySQL. So here it will be a design, I mean not design change, but there's a change. It will use the MongoDB. So you can see the Mongo Compass here. So where we have all the properties information, right? So like property type, address, construction type, occupancy type, so square footage, number of floors, year built. So like this, the properties information will be stored in the MongoDB. Then, um, then the property quotations information will be saved in the MySQL DB. So properties information, you all know, right? To create the property quotation, properties are needed. Now these properties are in MongoDB. So from Mongo, the properties are pulling. Once the properties are available for this property, the property owner will choose the coverage type, policy type, etc. So this quotation create, right? So that quotation is going to be stored in the MySQL DB. So we have the property quotation DB. So if you can see the quotation details, it is like this. So this is the property information, and then the quotation created date, and then quotation expiry date. And if you wanted to know more details about the quotation, there is a quotation details page. So if you can go to this quotation details, which contains what is the coverage type, what is the policy type, right? Everything. That's it. How these tables were. If you can see this property quotation DB, there were a lot of tables. So we'll see, meaning, for example, property quotation details table, if you can see the diagram. Yeah, this is what it's ER diagram, entity relations diagram, right? So property quotation details will have a many-to-one relations to the property code, many-to-one relation to the policy type, many-to-one to the code type, and then many-to-one to the coverage type. And if you can see the coverage type, AR diagram, sorry, coverage type diagram, again, the coverage type have the many-to-one relation from the property code details only. And if you can see here, the coverage underscore perils is another link table, which will have the, again, many-to-one relation with the coverage type. Don't worry about this database design and all we're going to do. Once this regular thing started, then we're going to do the database design and all. That's all from my side for today. Hope you got about the project concept and what we're gonna achieve and what's the problem we're gonna solve. I mean to say the market analyzer gonna solve and what is its system architecture is. Don't worry, I might have given you a very high level glance now as these are the demos, but going forward, we'll talk about each and every service, its functionality, and its system architecture and its technology, like complete high level details we'll discuss. That's all. Any questions for me? Oh, there
Uh,
are two questions. Yeah,
yeah, sir, we are using here two databases, right? One is MySQL and another one is MongoDB.
correct.
Uh, why we are maintaining properties in MongoDB instead of MySQL?
Okay, so first thing is what we are using the microservices architecture. So we have the property management service here. So properties management service. This properties management service will talks about the properties information. So the properties information is a complex object, first of all. I mean to say, if we can go and then see the properties. Let me go to the properties, right? So create property. So it's a complex object. So the properties have the basic properties information, and it have the address information, and it have the construction type, property type, occupancy type. This is one model, this is another model, this is one model, and this address is another model. Then this is the basic information. So if we can go with the RDBMS for this one, if I want to get the uh, first of all, I want to see only the very basic property details, right? So let's say if we go back to this, see, we are seeing the first basic property details. So what will happen is now, if we use the RDBMS, so we have to use the cascading relations for this one, which is a costly, right? I mean to say, if the property will be pulled, then property need to be pulled the address, property need to be pulled the construction type, and this a property need to be pull the property type, and then property need to pull the occupancy type. So these many tables it need to relate and then get the data back, so which will obviously takes a lot of time, right? That is for only one
Yeah.
single property. If we have the thousands of properties, lakhs of properties, right? Then imagine, for example, if I want to search a property which is in the Amirpet area by entering the pin code, right? So in order to bring all these details back, imagine how much time it will take by combining all the relational tables. So that's the reason we went for the NoSQL. So where everything will be a document. If you can see here, everything is simple JSON document, right? It's a text information. There are no relations, nothing. So it will take a very less time compared to the relational, foreign links and all, meaning associations. So compared to the foreign associations and then the linking the tables and then attaching the relations, right? So rather than that, it is a straightforward, right? So it's a JSON object. It's a plain JSON object which contain it's a complex JSON object which contains again another object inside in it. But though it is just a plain text, right? So performance will be obviously superb compared to the RDBMS. That's the reason we went to the MongoDB here. Make sense?
Understood, sir. Yeah, thank you, sir.
Perfect.
Sir, another question.
Mhm.
So
Go ahead, please.
we are going to maintain recommendations in one service, right? So we are going to
Mhm.
call AI.
Correct.
Which model we are going to use, sir? We are going to use ChatGPT,
Um,
OpenAI, or
yeah, so we have the various things like Gen AI, OpenAI, right? We have the other LLMs as well. So mostly we will use the um, I'm just thinking, and I'm just still writing the use cases and all for this one, but mostly we'll go with the either Gen AI or the OpenAI. Of course, OpenAI is the chat GPT one, right? So we go with the uh, I am thinking to go with the OpenAI or maybe the Gen AI.
got it, sir. Thank you, sir.
Not really sure. Okay, someone asked a question like, are we going to use the payment service? Um, let's see. I mean, right now, I did not add it in this architecture, the payment service. But we have the use cases as you already have seen, right? But I'm not guarantee for the payment services integration at this moment. We'll see if the time permits and then if we implement the system as desired, right? So then probably we can see about that payment gateway integration, or maybe if not in our project, I might conduct the weekend workshops, free weekend workshops. So in that free weekend workshops, we can discuss separate payment gateway integrations, and then we can integrate that with our project. Okay. Yep. Any more questions, folks? Great. Thanks a lot. And tomorrow's topic is again each and every service, its functionality, requirement, and its high level design, its architecture, how it is going to be, and its entity modeling, domain driven design. So all those things we'll discuss about each and every service. Probably the general concepts like DDD and all, if we can discuss only once, that is good enough. But each and every service specific functionality, requirement, its architecture, its technical stack. So those things we're going to discuss in our coming sessions. Thank you so much. If any questions regarding the course and all, please reach out to Durgasoft team. Thanks a lot.